Hi everybody, myself Dr. Trapti Gupta. Today we will discuss heat, work and internal energy. Now start with the concept of heat and work. We have already discussed that in order to define a system completely, four state variables, namely temperature, pressure, volume and concentration are required. Besides these state variables, there are two more variables, work and heat, which play an important role in defining a chemical system completely from the point of view of thermodynamics. These two variables are not a state function but they are path functions. Now the question arises, what is heat? Heat is regarded in thermodynamics as energy in transit across the boundary a system from its surroundings. Heat transfer results from a temperature difference between system and surroundings. Heat transfer ceases when thermal equilibrium is achieved. All other forms of energy can be quantitatively converted into work, but heat cannot be completely converted into work. This is an important point to be noted. Sign convention used for heat is opposite to that used for work. Heat added to a system is given by positive sign, whereas heat extracted from a system is given by negative sign. Heat is an algebraic quantity and is symbolized as Q. Unit of heat is same as work and energy. Now come to work. It is a mode of transference of energy between system and the surroundings. In thermodynamics, work is defined as any quantity of energy that flow across the boundary of a system during a change in its state. In general, when a force is acting on a body, it moves through a distance S. The work is said to be done. If a force acting on a body moves it through a distance S, the work done is expressed as work is equal to F into S. The distance must be in the line of action of force. Work is nothing but expresses force. Work is done against any external force. If the work is against mechanical force, it is called mechanical work. And if it is against an electric force or gravitational force, it is called electrical or gravitational work respectively. Work is the product of two factors, intensity factor and capacity factor. What is intensity factor? The external force against which the work is done measures the intensity factor. For example, if work is done against pressure, then intensity factor of work is pressure. And capacity factor? Capacity factor is the measurement of change in system due to work done against external force. For example, there is a change in volume in doing work against pressure. So here volume is capacity factor. For different types of work, we can define intensity factor and capacity factor as follows. For work of expansion, intensity factor is pressure and capacity factor is change in volume. For mechanical work, intensity factor is force and capacity factor is change in distance. For electrical work, intensity factor is potential difference and capacity factor is Coulomb. For gravitational work, intensity factor is gravitational force and capacity factor is height. And for thermal work, intensity factor is heat capacity and capacity factor is temperature. So we can see that from this table it is clear that dimension of work is same as dimension of energy. In CGS system, the unit of work is ox or dyne centimeter. Now come to another topic, internal energy. It is the energy associated with a system by virtue of its molecular constitution and the motion of its molecules. The contribution of energy due to molecular constitution is known as internal potential energy, and the contribution due to motion of molecules is called internal kinetic energy. We can say that total energy or total internal energy is the sum of internal potential energy and internal kinetic energy. There are some important points regarding internal energy. A fixed quantity of any substance under a given set of conditions has got a definite amount of internal energy associated with it, but this amount is different for different substances. It is symbolized as capital E or capital U. Absolute value of internal energy cannot be obtained, but we can calculate change in the value of internal energy. Internal energy of the system varies with the material contained in the system. So we can say that it is an extensive property. Similar explanation is true for delta E also. The magnitude of internal energy is determined by the state of the system, means it is determined by the variables pressure, volume and temperature. As these variables are related to each other by equation of state, that is PV is equal to nRT. And for a system of fixed composition, we can calculate the value of third variable if we know the value of other two. Similarly, we can say that for a system of fixed composition, internal energy is a function of any two of the three variables pressure, volume and temperature. So we can say that internal energy is a function of pressure and temperature, or we can say that it is a function of volume and temperature, or we can say that it is a function of pressure and volume. Unit of internal energy is joule. If a chemical system having energy E1 undergoes a chemical change and after the change have energy E2, then change in internal energy delta E is equal to E2 minus E1, because internal energy is a state function. It depends upon the initial and final states of the system. Suppose E1 is the internal energy of the reactant and E2 is the internal energy of the product. When internal energy of reactant is greater than the internal energy of product, that means E1 is greater than E2, the energy will be given out to the surroundings. So we can say that reaction will be exothermic, means delta E will be negative in this case. In the next case, when internal energy of reactant is less than the internal energy of product, means E1 is lesser than E2, the energy will be absorbed from the surroundings. In this case, reaction will be endothermic, means delta E will be positive. For any query, please type in the comment section and don't forget to attempt the quiz. Link of the quiz is given below. Thanks for watching. Thank you once again.